Good morning, Kang Jung. Good morning, Julia.
Good morning, dear Moritz. Good morning, selection committee. We're already here, you see, getting together. Half of the participants are already relaxed because they already presented yesterday, but we are still looking forward to hear the presentations of other colleagues. I heard the topics of their papers and their presentations, and must be very interesting today. Moritz, I like your vyshyvanka. Very nice.
Slava Ukraini.
Героям слава. Everyone responded. How are you?
Hi, good morning.
Good morning.
Can we ask one of the participants to tell us about yesterday afternoon and evening and overall how the group dynamic is developing?
Who can volunteer to tell a little bit about yesterday? Come on. Dear participants, who wants to say a few words about yesterday afternoon, what we were doing? Maria? You already presented yesterday. It's another chance to interact with all of us.
Yeah.
With the
Let's wait until the others are here from the selection committee. Maria, thank you. Let's wait for Elsa to join.
Yeah, I wasn't ready to give speech today.
You are ready.
I thought that yesterday it was my last presentation. Yes.
waiting for Maria to tell us more about yesterday afternoon. Morris asked someone of the participants to tell us about yesterday. Morris asked the participants to share their impressions of yesterday afternoon after the presentations. So Maria almost volunteered. I asked her to tell a few words as she's not from here and she already presented, so she's more relaxed and she can share her impressions. And now when everyone from the selection committee is here, I think Maria can say a few words.
Good morning, everyone. Yes, yesterday was a really good evening and a really good day, especially after my presentations. I finally got relaxed and can enjoy our beautiful competitions, this beautiful city Ivano-Frankivsk. We had gastro tour, food tour. I don't know how to call it in English. We heard a lot about food history of Ivano-Frankivsk, about some dishes that we eat but don't know from where it comes to us. Also, there was some dishes that I haven't tried before, especially from Krymsko-Tatarska cuisine. So I think we all enjoyed this evening. We all enjoyed these days, and it's. I feel a bit sad that today is our last day. But I wish good luck to participants who have today their presentations, and we are enjoying our time that left for us. Thank you. Have a good day.
Thank you very much, dear Marie. Indeed, it was a lot of impressions. We are getting closer and closer at each new interaction at all the tours. And it was interesting not only to the visiting participants, but also to the local participants, because being a tourist in your own city or town is also an interesting adventure. There's always something new to learn. But everyone is very excited to start the day. And yeah, the first category participants cannot wait.
And tell us about the lab tour.
The lab tour, the lab tour was extremely well, interesting as everything else. We started with the lab tour with Yuri Pelikan. He gave us a tour on the standards that they have, primary standards and the secondary standards. We had a lot of questions asked and the impressions shared afterwards about the tour. The participants later on asked about the specifics of the institute, because they work with oil and gas and they work with the University of Oil and Gas. So we had also a small lecture after the tour by our dear Taras Kepashchuk about the specifics, the peculiarities of the field, even though we had some free time, but we had more questions, so why not? I see that young people are not too shy, and they're not scared to ask for more information, to learn more, even though sometimes it's not even their field, but there's no limit to new knowledge. And today, after the lunch break, we will, and while you will be taking the most important decision for the competition about the winners, we will have a tour to the first, to another lab, to the primary standard, the Bell Prover, which is located on a different site. And even the young local metrologists that participate in the competition, it will be a new experience to them, because they haven't had a chance to attend that site yet. Moritz and I, we were lucky. We were there some 5 years ago, and we saw it. How shall we proceed?
Well, the competition can continue, I guess. Maybe there are some impressions from the selection committee members to start the day.
Well, I was very happy with the yesterday. So I learned a lot from the participants' presentation. So I was really happy about their performance, and I'm looking forward for today.
Thank you very much, dear Elsa. It's inspiring. So shall we start with the first participant from the category number 1? We have our dear Valery Ashchapkov to open the category for us and to start his presentation. Please join us here. And I'm giving floor to Valery.
Hello. My name is Valeria Shepko. The topic of my presentation is improving the efficiency of processing measurement result using machine learning. Today, there is significant need for effective method of detecting outliers in measurement data. Detecting anomalies or outliers in the processing of measurement data on mechanical measurement standards is a relevant task that is addressed using various methods and approaches, among which machine learning and statistical data analysis methods are particularly relevant. Therefore, to solve the task of detecting anomalies in research measurement data, within the framework of preparing the state primary standards of volume and mass flow rate of liquid, volume and mass of liquid flowing in pipeline, for international comparisons in the direction of mass flow rate of liquid, a machine learning method was chosen, the effectiveness of which was verified using a statistical method. The result of the study of the expanded uncertainty of measurement of correlated flow meter were used as input data for the machine learning model. As a result of the calculation, the relative measurement error of the correlated flow meter relative to the standard was obtained at several liquid flow rates, which formed 9-day sample for further investigation by the model. The isolation forest model was used for the study. The main idea of which is to use isolation as a method of anomaly detection, where anomalies date points typically required fewer steps for isolation than normal points. This is achieved by creating an ensemble of decision trees, each of which is built based on random selection of features and splitting thresholds. In this case, the features in the value of the relative error. As a result of the model's work, value of the degree of anomaly were obtained, which reflect how each value is anomalous relative to other values in the sample. To assess the effectiveness of the model, comparisons was made with the result of outlier detection using a statistical method. Initially, the Kolmogorov-Smirnov test, it was found that all samples belong to the student distribution. Due to the fact that the student distribution has heavier tails, the free standard deviation method was able to detect outliers in the data, reducing the threshold from free standard deviation to 1 standard deviation. Comparing the obtained values by the two methods, it was found that almost all samples had identical results. Minor deviations indicate the need for more precise tuning of the sensitivity of both methods for a complete match. Only in one sample was a significant deviation found, which is relative to the principle of operation of the isolation forest model. Two values in the sample were identified as anomalies as they are located between two clusters of values. So the forest model identifies this as anomalies. The main goal of this research is to reduce the standard uncertainty of measurement of type A. Both methods significantly reduce this indicator, indicating the effectiveness. However, it should be noted that the machine learning method is more effective as it is independent of the distributions provides a numerical value of anomaly for each value, allowing the result of the model of different sample to be combined for analysis of outliers in the data. For example, within one flow meter or one type of flow meter. Such an analysis combined with other machine learning methods will help investigation the cases of outliers in measurements. This will improve the accuracy and efficiency of measurement on the standard. Several articles have been published on this work, which are dedicated to the use of machine learning in the field of metrology. Conducted research on the standards and the use of the isolation forest method for detection anomalies in measurement data. Thank you for attention.
Hello, thank you for your presentation. It was quite fast. So I would like to ask you again why what is the advantage of using this machine learning method? So you can explain a little bit better to us.
First, deviation date, independence, and values of the degree of anomaly. Independent on the from the data distribution and the level of anomality degree.
I will help with the interpretation because Valery is overwhelmed. He's saying it in Ukrainian, but it's difficult to help him word by word. He will say it in
Okay.
Ukrainian and I will translate the sentence. It will be better
Okay.
and more effective. It will be his thoughts.
По-перше, це незалежність від розподілу даних, тому що статичні методи потребують розподілу даних, знаходити і методи, всі методи статистичні потребують певного розподілу та
Independence from data distribution, because all statistical methods, they require that data is distributed.
По-друге, це ступінь аномальності, яка допомагає бачити, як розподіляється кожна точка, кожне значення відносно іншого, і це
The anomality degree that allows to see how each point is distributed from each value.
кожне значення, якщо воно, наприклад, не дуже аномальне, воно приближено до нормального, яке вважає модель.
Ще раз скажіть. Скажіть мені, я перекладу. Ще раз повторіть мені, що я сказала. Просто те саме, що ви тільки що сказали. The value, if it's not too abnormal, we do not have to exclude it. If it's not too abnormal, we do not have to exclude it. We can see each value, how much abnormal it is. And all the statistical methods, they show only whether it is normal or abnormal. And then we can combine this sampling and we can see the overall picture. For example, in the framework of one flow meter, or the type of flow meter. And to study the measurement standard for the outliers overall on the measurement standard. This is
Okay,
it.
yeah. Thank you. It is a very, very nice job. It's just a shame that Valerie cannot answer it correctly in English, but he did in his own language. So thank you very much for your work.
Thank you. Thank you.
Thank you very much, dear Valerie. Thank you very much for the question, dear Elsa. And now I'm happy to invite Vladislav Katmai, another next participant that we have in the category 1 today. Please, the floor is yours.
Good morning. My name is Vladislav Katmai, and my topic is development, design, and modeling a test standard with a flow rate range up to 25,000 cubic meter per hour, ensure traceability to the national reference base maintained by C Internet Ivano-Frankivsk standard metrology. Due to the globalization to trade in and industry, the mutual recognition of standards and metrological protocol is a key factor. The development of test and traceability to the national reference base ensures the advancement in the independence of the field of volume and volumetric flow rate measurement of gas and accordance with measurement methodological describes the international standards. Its development is necessary for the efficient use of resource and optimization of cost and materials. Next. Next. Yeah. And gas materials diameters ranging from DN 300 to DN 500 are integral parts of Ukraine's gas transport system used for measurement to volume of gas passing through them. This methods enable the measurement of significant gas volume with minimal use of equipment and auxiliary devices. Next slide. Such methods employed in various industrial settings, particular of main gas pipelines, whereas they are positioned of different points of the maximum gas volume, and as well as power plants where gas used as an energy source, in gas storage facilities, and at industrial enterprises where largest gas volume are used in production process. Next page. Currently, this gas matter is not metrological supported in Ukraine. Therefore, the development, design, and modeling are working standard, specifically a test tent with a volumetric flow rate range up to 25,000 cubic meter per hour to ensure traceability to the national reference base maintained by Ivano-Frankivsk standard metrology is of great importance in context of the country energy independence. Next page. The working standard designed by specificity from Ivano-Frankivsk standard metrology with a maximum flow rate up to 25,000 cubic meter per hour consists of a system of pipelines with antennas to creating gas flow, a set parallel installed reference gas meters, and test gas meter installed sequentially is the reference meters. It includes of a regulation system, temperature and pressure transducer, and data collection, transmission, or processing system. The set of parallel installed reference meters includes for RMG DN 300, which are installed or parallel lines with the capability of simulation operation. The set of 6 RMG mechanical decoupled from the gas flow creation units with the test gas meter through specialty vibration insert. The 4 parallel reference lines with the RMG with the flow rate lows 6,500 cubic meter per hour and proportional the increase in the investigate flow rate. The gas flow regulation system throws the test gas meter and multi-stage and include flow creation units with the frequency controls of 4 lines and flow regulation with positional control stabilization flow under a different operation model and the unit and wells with the rotating drives and positional control ensure prices for setting each reference line. Next, please. The parallel use of such reference gas meter within the devices allow for increased range of reproducible flow rate depending on the number of installed and engine reference gas meter. This ensures the traceability of the measurement of national reference by specific to the secondary standards and gas volumetric flow rate, range up to 6,500 cubic meter per hour. This achieved by calibration as this reference gas meters directly on the VA2 using the reproducible flow rate range. Next slide. Calculation of the expanding uncertainty of the reference installation of performance during calibration. Calibration of the specific channel and carried out parts the installation to exclude the influence of assembly, ensure hermetic sealing and verify operation of the software. For calibration, pressure calibrating as a thermostat with a reference thermostat and frequency meter are used. For each channel, the component, the total uncertainty is determined according to type A and type B. Calibration of gas volume measurement channel is etc. The reference meter is carried out using transfer stands and transfer standards undergo periods of calibration of national prime and secondary standards of gas volume of flow. Additionally, the calculation of eccentrically component caused by effect of volume accumulation due to temperature change during verification is performed. To reduce the influence of this effect in installation design with the application of 4 parallel lines, then 300 for the installation of meter with the possibility of isolation education connecting volume. At the same time, calculations are made or for each reference made in the installation. The calculation of this uncertainty component is performed according to the following formula. Next page. Formula 1. Next, Formula 2, and next, Formula 3. Next page. The outcome of this working is development implementation of a working standard for gas volume and volumetric flow rate up to 25,000 cubic meter per hour, which will be utilized the for the verification and calibration of gas meters. The application of this working standard enable research activity, thereby ensuring traceability of the national reference base. This development will serve as stimulus for energy independence and economic growth in the country by expanding the range of volumetric flow rates, enhancing the reference by Ivano-Frankivsk standard metrology, and reducing expense of equipment calibration abroad. Since the specialists Ivano-Frankivsk standard metrology are capable of performing this task, including the calibration and the setup, ensuring metrological traceability, the expenses for this process will remain with the country contributing to the conversation or financial resource and to the support on internal economic potential. Thank you for your attention. Я їх закличу відвідати, коли ми закінчимо.
Thank you for your presentation. I have one question about your research. So I could understand that you have established some kind of a standard which can measure up the flow rate up to 25,000 square meters per hour. So my question is that you never had that kind of standard to measure the flow rate before your research. And the other question is that maybe your customers in your in the gas companies are also asking you or to the NMI of Ukraine to develop this technology. Could you please answer that?
No, it's a first stand in Ukraine. We first building the stand in Ivano-Frankivsk. I don't know, maybe in the future people will want to buy this. Yeah, the moment the clients so many already happy.
You mean this technology is already used in the industries?
Yes. Yes, we use this technology. We have clients.
Okay, thank you very much.
I would like to comment from my side, from PTB side. Thank you very much for your presentation. It's a very exciting project plan for the Institute for Ukraine, which should become reality soon. And to your question, Kang Jung, so it's connected to the transcontinental pipeline between Ukraine and the EU. And the plan is to provide traceability here. And PTB has ordered the 4DN 300. So we are expecting delivery within the next 4 months. So yeah, the company RMG is now producing these devices. So the plan will be implemented very soon.
Thank you. I think maybe in near future we visit the stand We are welcome. Maybe you can read about this stand in Workspace Ivano-Frankivsk Standard Metrology in next month or near future. Maybe in Facebook page, website, yeah, Workspace page, maybe you're reading about this stand. Thank you. Bye-bye.
Thank you very much, Vladislav. And thank you very much for the questions. The next participant in category number 1, we have Alexey Mochurad ready to present. Please, Alexey.
Good day. Um, Hello, my name is Alexey Mushrat, and I want to talk about infrared temperature measurements. So, the importance of the radiation coefficients in temperature measurements is the importance of the radiation coefficient, measurement of surface emissivity, and direct impact on the result. Emissivity is critical in infrared temperature measurements because it directly affects the measured temperature. It determines how well an object emits abrupt and reflect external light. The value of the emissivity varies for different surfaces under the influence of such properties as heating, physical and mechanical treatment. The emissivity plays a significant role in infrared temperature measurements, and the direct impact on the result. The value of the radiation coefficient directly affects the accuracy of temperature measurements. Understanding and controlling this factor is essential for accurate and non-contact temperature measurements. Okay, there we can see factors affecting the radiation coefficients. It is wavelength, surface temperature, and measuring angle. Wavelength, we have seen how it how change when I change temperature. Surface temperature, since the surface of the material can change its properties according to the radiation coefficient occurs a different wave, and measuring angle, irregular Helsing surface, and reaction infrared wave may significant affect the measurements results. Determination of the radiation coefficient, we have a material transparent and non-transparent. With this formula 1 and 2, we can calculate radiation coefficients. This information is the surface relative coefficient, is the transmittance of the surface, and is the surface radiation coefficient. And we can spectral radiation coefficient. The spectral radiation coefficient of the surface is defined as the ratio of the spectral length of the radiation of the surface and the spectral density of the radiation flux of the absolute black body. Depended on the wavelengths. There I have a research when I measure a temperature of this object with a contact thermometer and pyrometer, and There we can understand how may change temperature when thermometer is shifted in 1 millimeter left. This information about radiation coefficient when determined for the well line 0.65, but other temperature. So, for example, aluminium and aluminium X oxidants when he grows temperature and the same have determinator for the well lines 0.65. It change radiation coefficients. So in this graphic, radiation flux intensity, the surface is completely black body. The radiation flux density of an absolute black body in the range of wavelengths can be optimized by integrating the Planck's equation lambda within the given limits. In perimetry, we other use black body. Value of wavelengths in infrared temperature measurements, value in non-contact measurements, and the communication with temperature value. Wavelengths range for infrared temperature measurements. So non-contact infrared temperature sensors typically operate in specific wavelengths range to provide accurate and reliable measurements. Those range are determined based on their ability and minimal absorption by atmospheric gases. So in our industry, object use the main range of wavelengths. Short wave infrared range 0.68 to 3 micrometers. Mid wave infrared range for 3 to 8 micrometers, and long wave infrared 8 to 14 micrometers. This is more popular. So for a more detailed overview of the influence of different wavelengths in infrared temperature measurements, we use a mathematical model that will allow us to see the result with different value of the measured temperature and wave range according to this formula number 5. So we use wavelengths to lambda 1 to lambda 4 to sorry from 8 to 11 20 12 and lambda 3 and lambda 4 from 7 to 14 and we have this result. So in this we can see that this machine we calculate from this wavelength diapason and degrees Celsius 20 and 100. And we have this result that talk about that change of the value describes change of result. So result of the effect of wavelengths on temperature measurements, practical implications. The effect of different wavelengths range on temperature measurements is of practical importance depending on the context and required measurements accuracy. Understanding this implication is important when selecting measurements equipment and performing non-contact temperature measurements, because this our parameters is very important when we need high accuracy. Thank you for your attention.
Thank you very much for your presentation, Alexi. I would like to know if you know what is the difference in terms of variability between this type of thermometers and the normal immersed or PT100 thermometers, for example. Do you know the difference in terms of variability? So standard deviation, for example, or uncertainty. What is the difference, and if we can actually trust this kind of thermometers?
This is very other instruments, because measuring of temperature make in other specification, because in glass thermometer we all know that inside and is one value, and in digital thermometer we have more and more different contributing values. Some I name in my work some of them, but it is not all, because we have a temperature we have a temperature for around, we have a distance to object, and more other influencing factors.
Okay.
Thank you.
Thank you.
Hello there, Alexei. I would like to ask just a general question. What did you find as a benefit of this study to your practical work?
We have in this research we can see that the change of values can vary influence to result. Let me short. Yeah. For example, this we have one determinant for the wavelengths, but we have other material in other their in other temperature, and we see how how change radiation coefficients. It's one of influencing factors. I answer in your questions because
Okay, thank you. I just wanted to ask in general, and no need to show these tables. Just for your practical work, what do you feel was it worth or no investigation? Okay, thank you.
Okay, for my practical works, it is important because when we verification instruments, we must have instruments with the same characteristics. Because when it is other, we have unwanted result.
Okay, thank you again.
Thank you. Thank you for your attention. Goodbye.
Thank you very much, dear Alexei. And as usual, we're a little bit ahead of time, so I suggest that our next participant presents now. And I would like to invite Bogdan Olinichenko to present his work. Of the category 1 of today. Please, Bogdan.
Hello, everyone, dear colleagues. Dear colleagues, I am glad to present to you my review work on the topic of Color Fidelity Index. This review work is based on the material on the Doctor of Technical Science, Professor Nazarенko Leonid Andreevich. Color rendering is a very important quantity that shows how we perceive color. For example, everyone knows well that a sodium lamp has a yellowish tint, and there are usually cases when we buy a jacket with one color in a store, and then we go outside and see that the jacket is completely different. That is, it all depends on the light source. We should have a metric that would show that this light source conveys natural color well. Of course, it depends on the spectrum of the light source and has excited for a long time. Since 1995, the MKO metric, it is the index of general color rendering and the index of color rendering. But back in 2007, the International Commission noted that the color rendering index, the usual CRI, cannot be used to predict the color rendering parameters of a set of light sources if this set includes white LEDs. That is, this whole system turned out to be not very congruent when the LEDs already appeared, and this whole system failed. How this classic system worked? You have 6 to 8 samples, but in reality there are 14 samples of certain colors, and you have reference light sources. Which are reference? This is daylight, this is black body radiation, this is what is called a reference emitter type A. This is an incandescent lamp with a temperature of 5856 degrees. So you take a certain reference sample, shine it with a reference source, and then you want to investigate a new light source. You take and compare what the real reaction is and calculate what is called the color rendering index. Overall or individual, you know the so-called color shift. Since this all turned out to be insufficient, it was first proposed by the Americans, namely from the Association of Lighting Engineers of North America, who proposed a new index of color rendering called the Index of Color Accuracy. What is the difference? The difference is that instead of 6 to 8 samples that you look at, how color is transferred, you take 99. Of course, 99 is much more, and besides, a completely different color space is taken. Most metrics which were proposed for assessing the color quality of the light source are based on the evaluation of the differences occurring in the appearance of color test samples illuminated by reference source and lamp under evaluation. The color rendering index CRE, defined by ICO, and particular the general color rendering index RA, is widely accepted and used in the lighting industry in regulatory documents. International and regional standards are specifications. However, CRE limits have recently been reactualized, especially for solid-state light sources, where RA values don't always correlate well with the visual judgment of ordinary consumers. This discrepancy arises primarily from the inaccuracy of CRE in their intended role as an index of color fidelity, and both of these aspects require better color characterizations and methods for measuring and specifying white light sources. The general index of color accuracy, RF, represents how closely the color visual sensations of the entire range of samples reproduces or transmits. On average, under the test light as compared to its reference emitter. Similar to the general color rendering index RA, the general color accuracy index RF combines the calculated color differences for all test color samples into a single average index value. And there is only one aspect of color quality that doesn't consider the effects of sensation and preference. The compression with the CRA method in CRF calculations, the number of color samples, is changed from 8 to 99. Those set of the color samples were designed to reliable uniform color distribution in the color space. What is CF1 standard illuminant? The CF1 standard illuminant is one of a series of standard illuminants defined by the International Commission on Illuminant CE. The F series of illuminants are intended to represent typical fluorescent lighting conditions. Specifically, the CF1 illuminant is known as cool white fluorescent, and it's characterized by its spectral power distribution that simulates the light output of a typical cool white fluorescent lamp. Here are the examples of CF1 in different methods. So here one, and here 16 hue angle beams for the CF1 standard, and the color vector graphic for the CF1 standard illuminant. Then the CAM02 UCS color perception space is used to calculate color shifts. The most advanced modern uniform color space is called CAM02 UCS. Its name consists of CA color appearance model, MKO model of color perception. UCS, uniform color space, is a uniform color space in the sense as equal distance in space represent approximately equal with visual sensation of color differences. So the built-in chromatic adaptation and the implicitly adapted white point in CAM02 UCS provide advantages because the accuracy calculation is largely independent of the CQT of the test light source. The IS-TM 3015 method, developed by the Illuminating Engineering Society IES, provide a comprehensive framework for evaluating the color rendering characteristics of light sources. Two key metrics in the framework are the IS gamut index and the IS fidelity index. Understanding the trade-off between these two indices is crucial for selecting the right light source for specific application. So what's conclusion? Conclusion is 99 test samples method is much more better. It's really superior in its ability to provide a detailed and accurate assessment. So of a light sources color rendering capabilities. It uses a comprehensive set of 99 color samples and representing a broad spectrum of real world colors, making it highly suitable for modern light sources with complex spectral characteristics, while other methods offer valuable insights and specific advantages. The 99 test samples method excels in comprehensiveness and precision, making in the best choice for evaluation color rendering performance. What has now happened in the world? Unfortunately, the International Commission didn't accept this standard of 99 test samples. It writes that this is really a scientific achievement, definitely better than the old standard, but it needs to be continued so that it can be introduced as a standard. What is the idea of this work? We have an excellent photometric laboratory in our Biketova National University that can measure all of these parameters, including the color factor using our system. If this new American system were already implemented in our photometric laboratory, then we would have the first one in Ukraine that could make all possible color measurements. Thank you for your attention.
Thank you for your colorful presentation. I would like to ask, you talked about some standards. What type of stakeholders are interested in it, and who are using it? What kind of fields in practice needs for these standards?
In practice, standard CRI is too global and it has grown too deep to change this standard. CRI, which is a raw characteristic, but it's not perfect and it should be changed. So all the light source producers, they are interested in to change the standard and to make it much better.
So you see the future of your investigation, yes? You will try to insist to arrange this new standard.
Yes.
Thank you for your answers.
Thank you very much for your presentation. Can you tell me a real application for the real world of your work?
The real application is that to make color rendering is more accurate. So when we use 99 test samples method, we make much more more accurate results, and we could make better results. So.
And what kind of industry will benefit from this?
A lot of industries like lighting industries, like any industry where the color is dominating characteristic. So it's a really big spectrum of industries.
Okay, thank you.
If I may ask a question, this is an interesting topic, but you said that the International Committee had not accepted this 99 test samples method. Could you tell us about what specific deficiencies they noted that prevented them from adapting this new method, and what work needs to be done in order for them to reconsider their position?
As I understood, the old standard is too global, too поширений, too widespread in the system. So to change this standard takes much more efforts to change the standard, and it's better to for them not to change it because it's very commercial question.
Okay, so it's a matter of cost really rather than any sort of deficiency in the method.
Yes.
Okay, thank you. Mhm.
Thank you very much.
Thank you very much, dear Bogdan, and we are very well on time for the coffee break. But we have one event today that we are happy to be present at. Today, to camera. And no, today we have our dear participant Volodymyr Myslitsky, who presented yesterday, and he's celebrating his birthday with us today. He was lucky to present yesterday, and we would like to say happy birthday to him. Just a second. Можно торт? Just a moment. Just a moment. The surprise takes a little of the suspense. Let's sing. Happy birthday to you. Happy birthday to you. Happy birthday, dear Volodya. Happy birthday to you.
Yeah.
Make a wish now. Just be careful. Do you see it? Oh, to nie ta kamera. Okay, it's it's a long candle. You can make all the wishes in the world. So now we're going on a coffee break, having some nice cake and saying the best words to Volodymyr on his birthday. And we will see you very soon. We wish we could share this cake with you too, dear selection committee.
Yeah, I would like to taste some.
Yes.
Next
Enjoy.
time. Like, enjoy.
Thank you. Thank you. We will see you soon.
Enjoy.
Thank you.
You're
So,
muted, Julia.
yes, I
Oh.
moved on my laptop. Yes, different system here. Many cameras and laptops. We have to find solution. Now we're back from the coffee break. We have all said all the best wishes to Volodymyr. We all tasted the big, nice summer cake, and the participants that still have to present feel, I think, good and relaxed and hopeful that the presentation will be nice and smooth. And we are ready to continue. Shall I introduce the next participant to take floor and present, or would you like to say a few words? Shall I invite Andriy? Okay, so our next participant to present today is Andriy Savka. He's ready and he's coming. Join us, please.
Hi. Experimental questions. Tak, чути? Experimental studies of the additional air due to air humidity on the work of thermoanemometrical sensors. Student Andriy Savka of Ivano-Frankivsk National Technical University Oil and Gas. The relevance the relevance of measuring the volume and consumption of wet gas is considered. The possibility of measuring this parameter with devices use thermoanemometric sensors is shown. The given algorithm and technical support for counting studies of the effect moisture on the readings of thermoanemometers. The results flow measurement with a thermal anemometer and gas meter are given obtained experimental values of the air due to presence of moisture in the airflow. Working environment, thermoanemometric sensor, air humidity, and air consumption, gas matter, moisture generator, and additional error. Correct accounting of natural gas must be inserted by control its quality characteristics. At the same time, the greatest attention is paid to the control of it heart of combustion, which makes it possible record natural gas in angry units. At the same time, it's assumed that the gas is dry, that is relative humidity when accounting according to regulatory documents in Ukraine should not exceed 10%. The conducted analysis shows that flow meters and counters using thermoanemometric sensors can be used to measure the volume of wet gases. They are endowed with a wide range of measurement of flow be used to measure the volume rates, low interior simplicity of construction, and well as the possibility of measuring blasting flows. This is confirmed by a study of modern trends is the development thermoanemometry in the field of natural gas recording. The reports of the work is experimental studies of the effect of moisture on the accuracy of their measurement of speed, their consumption of wet gas flows. Mathematically, the algorithm for determining the mass flow of wet gas can be presented as follows. Where Vk is the control volume of air, the inlet of the installation of the measuring cycle, cubic meter, T is the duration of the measurement cycle as Phi1, P1, T1. It's relative humidity, absolute pressure, and absolute duration of temperature of the air under operation countings as the inlet of the installation. P, Phi max is partial pressure of water vapor and is started state under the operation countings of the installation. Pascal and Kelvin, it's a compressibility coefficient of the working medium at the installation inlet. Rho C, yes, it's air density under standard conditions, kilogram per cubic meter. And P, Phi1 is the density of water vapor in the air, the inlet of installation, kilogram per cubic meter. M, Phi G, it's mass of moisture generated in the installation during the measurement cycle, kilogram. The installation works as follows before, next page, please. Oh, no. Before starting the test, the shadow wave 2 is opened and laboratory installation beforehand with the help of the follow source 1 and the pressure regulator 3, number 3. The operating mode of the laboratory installation is yet with the help of the setter number 10, the operation mode of ultrasonic generator number 9 is selected in accordance with set follow rate is an input of the installation of archive to predetermined follow moisture generation parameters. According to the operation algorithm of the installation, the gas flow through in the inlet pipe to the gas meter number 4. The timers is number 5, forms the duration of the measuring cycle of the installation. That is the control volume of gas, which necessary from measurements is formed. The gas flow is mixed with moisture, which is charted by the moisture generation section number 6. The moisture generation section includes a container with water number 7, which is placed of reference scale number 8, with which water before and after the experiment makes it possible to determine the mass of generated water vapor. To generate water vapor is membrane. Number 9 is used, which vibrates with a frequency or throat, and the intensity of moisture generation set is by setter, it's number 10, which changes to the amplitude of the membrane oscillations after mixing. The incoming gas follow with generated moisture in the upper part of the container. It's number 7. The wet gas flow enters inversion. Section number 11 of the installation is equipped for sensor of thermoanemometric flow converter. The computer is on it 14 receives data on the measured volume and of air number 14, number sitting as number 14. At the inlet of the installation is pressure line 17, temperature is line 16, humidity is line 15. In the test section of the installation, the pressure of the working medium line 21, this temperature line 20, humidity 10, 19. At volume and gas line 18 are measured. On line 18, the signal of the thermoanemometer is sensed, which is previously converted into the measured value of the volume of gas during the research through duration. The duration of the experiment line, line A, the value of mass of generated moisture line B, and the follow rate line B are recorded by a stopwatch. Targets 1 is functional scheme of the installation of studying the influence of moisture of the generation of the operation of thermoanemometric sensors. And next page, please. Shows 3 results of flow measurement with a thermoanemometer, which is indicated by different marks and increments in the moisture content. of the airflow to the operation of the thermal anemometer leads to increase in the results of volume flow measurement by 17.4% when generated moisture 1.11 10 minus 6. By 31.9% when generated moisture 1.36 10 minus 3. Yes, no, yes, yep, degree. No, thanks. Gram per second by 40.9% at moisture generation of 2.2 10 minus 3 degree gram per second. The difference in the follow measurement results the absence of moisture generation is 2.7%, which is with the error limits of the thermal anemometer and the gas meter. The nonlinear influence of the increase in airflow humidity on the operation, the thermal anemometer at flow rate of 1.44 cubic meter per hour was experimentally established, which leads to increase in the measured volumetric from rate up to 40.9% and moisture generation of 2.2 10 minus 3 degree gram per second. Ну, не, грам, так. І наступний. І наступний екран. Thank you for attention. А якщо можна попередній? Так. It's installation design of the thermal anemometer in research. Number one, it's thermal anemometer sensor. Number two is outlet pipe of experimental site. Number three is thermal anemometer visualization on it. Number four, it's connection line between the thermal anemometer sensors and visualization on it. Number five, it's humid air supply line to the experimental plot. Number six, plus preserving line. It's number seven, it's line. That's all. Thank you.
So I think we can start with the questions. If I may, I'd like to ask you, what do you see as the impact of this work? How do you think it will generate benefits? What do you see? How do you envision it affecting the stakeholders, your customers?
Economics of Ukraine.
Sure, but can you be a bit more specific? I mean, what generated the need to investigate the effect of air humidity on flow rates? I mean, was there a need that motivated this? What will be the benefit? How will you
low humidity gas.
is it generally assumed, is there actual control of the humidity of gas made regularly, or is it just assumed that it has carries particular characteristics? Is that something that is controlled already, or?
Yes, it's control. No.
Okay.
Natural gas exceed 10%. Yes, of humidity.
Okay.
Thank you for your presentation. I have one more question. So why did you set the humidity as the 10%? Because I don't know why you specifically set the humidity in 10%. I'm not quite sure about that.
The indicator of our natural gas. It is indicate natural gas.
You mean normally in the natural gases, they have 10% of humidity. You are saying that?
Yes.
Okay, thank you.
I also have a question. Thank you for a presentation. How many flow meters did you test? Was just one or was different flow meters from different brands?
Yeah, yes, one. Yes, one I used 1 meter.
Okay. Okay, thank you.
But 1 meter, no, but 6 tests. 6 tests on 1 meter.
Okay, so you did some repeatability tests. Okay.
Yeah. That's all.
Thank you very much, dear Andre, and thank you very much, dear selection committee, for the questions. I would like to invite here the participant, Valery Semenikhin, who will present his presentation. And I would like to say that he will be the last one to present today, because the participant, Mr. Andrei Voronich, did not make it to our competition today, and he will not be presenting. So I'm kindly inviting Valery to present his work here. Please, you're kindly invited to take the floor.
Good morning, dear colleagues. My name is Valery Semenikhin. I am a junior researcher at the National Scientific Center Institute of Metrology, Kharkiv, and postgraduate student at Kharkiv National University of Radio Electronics. Today, I will present to you a report topic of identification of non-polynomial calibration dependence accounting for instrumental uncertainties of measuring instruments. My research supervisor is Professor Igor Zakharov, Head of Information and Measurement Technology Department, NURE. The report discusses the solution to the problem of uncertainty evaluation of the non-polynomial dependence identification accounting for the instrumental uncertainties of the measurement values. The measuring instruments MI response is measured at an calibration point of the considered range x first, x second, xn to plot the calibration dependence of the MI. At each j calibration point, measurements of the MI readings yji are carried out and repeat n times. Based on the measurements, a calibration dependence is plotted and its approximation is carried out by a mathematical dependence. Finding the parameter of the dependence is most often performed by the least square method, LSM, which provides the best results when the approximation dependence is a polynomial. In metrology practice, one often has to deal with the case when an increase in the degree of the polynomial within reasonable limits doesn't lead to significant degrees in the approximation error when identifying a non-linear calibration dependence. In this case, the transformation of the original dependency, formula 1, within linear dependency, formula 2, by the change of variables, formulas 3 and 4, is applied. Expressions formula 1 for nonlinear functions, formula 1 reduced to linear ones or given in the first column of table 1. The second column of which contains expressions formulas 3 and 4 for the functions. This slide, it's table 1, basic expressions for implementing the variable replacement method. When evaluating the uncertainty of the calibration dependence formula 1, one should take into account the uncertainty of the values of the output signal UY of the MI. The values are evaluated both by type A and by type B, as well as the uncertainty in determining the values evaluated by type B of UX calibration points. It should be considered that since the values of y and x are directly measured with the help of the MI, the instrumental uncertainties uy and ux must be recalculated into instrumental uncertainties u sub y and u sub x formulas 5 and 6. The expressions for the sensitivity coefficients Cx and Cy for different initial dependencies are given in the 5th column of table 1. After identifying the linear dependence, it is necessary to perform its inverse transformation into the original one, according to which it will be necessary to calculate the uncertainty of finding the value x for any value y. The values of the coefficients a hat and b hat recalculated from the obtained coefficients are given in table 1. Expressions for the sensitivity coefficients Cx, lining uncertainties Ux and U sub x for different initial dependencies are given in the 5th column of table 1. The expressions for sensitivity coefficients, lining uncertainties formula 7 are given in the last column of table 1. The general linear dependency has the form formula 8. Using dependence formula 8 instead of formula 2 eliminates the correlation between estimates A0 hat and B hat. First, according to the experimental points, the dependence formula 9 is plotted, which is approximated by one of the functions y equals functions of x, a, and b of the first column of table 1. The initial dependence formula 9 is linearized using the expressions from the second column of table 1. The estimates of the linearized dependence coefficients a and b are calculated using the expressions formulas 10 and 11. According to the obtained values a hat and b hat, the values of the coefficients capital A hat and capital B hat are calculated using the formulas from the third column of table 1. Obtaining a model of the original dependencies, y equals functions x, a hat, and b hat. Measurement uncertainty evaluation using the undefined dependence. First, for a given value y, the value x is calculated according to the corresponding formula x equals function inverse y, a hat, and b hat from the first column of table 1. The uncertainty of finding the value x is calculated by formulas if xj are not correlated. If the values xj are correlated, the standard uncertainty u LSM x is calculated just as formula 13. Uncertainty u LMS x is recalculated into uncertainty u LSM column capital X according to formula 7. Using the values of the sensitivity coefficients Cx from the last column of table 1. To confirm the solutions presented in the report, an experimental was carried out with a diode converter at the input of which square wave voltage x value was applied using the generator G5/16 and the converted y value was measured at the output using a voltmeter V723 voltmeter. The measured and calculated values as well as the graph of the dependence of the input and output quantities you can see on this slide. This slide shows the results of linearization measurement values and the dependence graph obtained after linearization. Also in table 3, calculations are presented according to the algorithm for identified the desired dependence given in section 2 when using a linear dependence of the general form. In table 4, you can see the calculation performed to evaluate the measurement uncertainty using the defined relationship and the graph of the uncertainty u LSM x of value of uncorrelated xj in this case. Results. An algorithm for identification of non-polynomial calibration dependencies, which can be reduced to linear dependencies by change of variables, has been developed. The parameters of linear dependencies were found by the least square method. Second, the procedure for measurement uncertainty evaluation using the identified dependence is given, taking into account for the instrumental measurement uncertainties of the responses of the calibrated measurement instruments and the values of the calibration points. An example of identification of the diet transduce transfer function by the developed methods is considered. Thank you for your attention. Your questions, please. Do you have any question?
I just have a comment because this is a very complicated activity with a lot of statistical analysis and a lot of calculations. So it's very difficult for the person who is not within the field to understand the concept. But anyway, I would like to congratulate you for the subject, to propose this subject. And I have no questions, but I would like to just to acknowledge that there is a lot of work done here.
Thank you. Thank you very much. Thank you for your attention. Goodbye.
Thank you very much, dear Valerie. Dear selection committee, I think that it was a nice experience for everyone, and we had 2 fruitful days of presentations, and now the ball goes to the field of the selection committee, and I think that now you have a very hard job, very hard work to do to select the winners of this first European competition of the best young metrologists in Ukraine. Would you like to share a few words before we go and you go to your meeting to define the best of the best?
Well, again, thank you very much for all your presentations. I think we had very different subjects presented, so very interesting activities that you do there in your laboratories with the purpose of improving the meteorological system in Ukraine. So thank you very much for sharing all this work that you do. Very, very good work. And congratulations to all the presenters for the very nice job. It was a very nice 2 days.
Yes, my congratulations to all the presenters as well. It's going to be actually a difficult job now to rank these. I think everyone is actually a winner. There's absolutely no losers in this competition. So thank you to you all. It was definitely interesting, and it's impressive the wide variety of subjects that we've seen. So it gives us an idea of the breadth of the work that's being undertaken over there. So thank you very much.
Thank you. Thank you very much. Thank you very much, dear Elsa. Thank you very much, dear Omer. Dear Moritz, I see that you would like to say a few words.
Yes, I also would like to congratulate all participants for your performance, for the paper submitted, for the presentations. It has been a pleasure to see you performing, to see you dedicated to your topics. So yes, we will see how the selection committee will solve the issue of ranking. According to the agenda, we still have some time, and we may give the floor to the participants to ask some questions to the selection committee if there are questions of interest to the different institutions and persons present here. So maybe we can have a discussion now a little bit. If not, then we would proceed to lunch, no, and to the lab visit that you do and to the meeting of the selection committee. But as there's some time, the floor would be for the participants to talk with the selection committee members on general issues.
So, dear participants, would you like to ask any questions our selection committee? Anything of interest, not competition specific, just the opportunity to talk, to communicate, to become closer, because we are all in this same boat of the competition, and we became closer. Starting Tuesday, we know each other, and please, the floor is yours. If anyone wants to ask a question. Okay, I think before the decision is taken, they're hesitant to ask a question. I don't see volunteers, unfortunately. They say that they want to say thank you for your patience and for your attention. Would you like to say it, Vladislav? Please.
Very thank you. It's amazing adventure. I really like, and maybe I think I love you. It's an amazing jury, people. Maybe my friend Yuri next say about this project.
Yes, it's an amazing journey for me. I didn't have this experience earlier. It's my first practice English now. Before I just reading English, it's my first speaking experience for English. Thank you for making this competition. I love you.
Okay. I just want to add that was a really great journey for us. This 2.5 day and was excellent. The organization of this event was unbelievable. I never see or heard about such a high level of organization, and I'm just say thank you for your judgment, because your questions were not really hard. Yeah, I mean, all of us know their work. Their projects were good, and they know how to say it in our language. Yes. So thank you.
It was a very good chance for all of us, and I want to say thank you for all of you for this chance, and it was amazing. Thank you.
The only thing that I want to say to you is that I hope with the next time we will meet offline, not online.
Thank you. It's a great experience for me, and I want to share it with my colleagues from my center. And I hope in future, in the second competition, some of them can came for its competition. Thank you.
Thank you for attention. Thank you for support, and especially for your support in difficult times. Thank you for the opportunity to learn and improve together. I love you.
Thank you for organization this conference, and thank you for new experience. Thank you.
Thank you very much. Це було the best. Дякую вам.
The dear selection committee, just as we started saying all the nice words, we had a power cut. Therefore, I am a little bit of the operator, camera person, so that you can see everyone, because the projector is not projecting on the screen. But we had a nice chance and opportunity to be all together during these several days, and we will be looking forward to your decision very soon after, well, as soon as you have the decision, as long as it may take. We are ready to wait as long as necessary.
Did you actually hand it over the souvenirs already?
No, we're going to do it with the nomination of the certificates and the winners. So this will be like
Okay.
nice package.
In the closing session.
Yes.
Okay. Good.
So we will meet now in teams for the selection when it's time. Yes, Moritz? We will do the
Yes.
rest of the meeting in teams.
Yes, we can continue if you agree in teams.
Should we do
Sure.
it now, or should we wait for the schedule?
I'm flexible as you wish.
If everyone agrees, I think we could do it now.
I agree.
Yeah, I think we have some time, so it would be good so we can do that now.
Okay.
Okay, thank you very much. We will leave you and give you all the time that you need, and we will be looking forward to see you soon. All of us will be here.
Okay, so we switch to Teams then.
Okay, see you.
Bye-bye. Thank
See
you.
you later.
Bye.